Hey everybody, welcome back. This is the November 20th, 22 quarterly review video going over the practice test. So let's jump right into it. This is your practice test. So if you've done it and want to check yourself or you want to do it now, pause after each question because I will go through all the explanations. Question number 1 says consider the following reaction. You have 2H2 gas plus O2 gas gives you 2H2O gas. What kind of change do the reactants? So again, reactants are stuff before the arrow. And then the things after the arrow, what is being produced is called your products. So what kind of change goes on? At this point, we haven't talked about nuclear change. We haven't talked about atomic change. So don't pick something that you haven't talked about yet. Then we have phase change and chemical change. So in a phase change, which is a type of physical change, you have the same compound just going from a solid to a liquid or a liquid to a gas. It's the same chemical formula. But if we have H2 and O2 in the beginning, and we're making H2O, we have different chemical formulas before and after the arrow, which is a chemical change. So if the letters are different before and after the arrow, that is a chemical change. If they are the same and only these things change, that is a physical change. Chemical change, you're making new things. Physical change, you're just changing the appearance of it. Number 2, which particle diagram represents a mixture of an element and a compound. So whenever you have these particle diagrams, it is a great idea to start with labeling it. So something can be a compound, like this. A compound is 2 or more different colors connected together. This black one and then this white one, these are diatomic elements. So 2 of the same color is still an element, not a compound. It's a diatomic element. That element cannot go anywhere without its twin. If you have a singular circle all by itself, that is a monoatomic element. This is another diatomic. And then compound, because you have 2 or more different colors, and this is a diatomic element. So the question says mixture of element and a compound. So the only one that has both is answer choice D. Question 3, which statement describes the structure of an atom? At this point, you need to know what an atom looks like. You have protons and neutrons inside of your nucleus. Protons are positive, neutrons are neutral, so the overall charge of a nucleus is going to be positive. And then you have your electrons floating around outside. Electrons are negative. So we have a positive nucleus surrounded by negative electrons. Number 4, which notation represents atoms that have the same number of protons but different number of neutrons? That is a definition of an isotope. So you want the same element but a different mass. So you want the same element symbols. So right there we can get rid of A and we can get rid of D. Now an isotope is the same element but a different mass. Same element, different mass. And so this number is your mass number. So in B you have S32, S32. That's exactly the same. But in C, you have, it's still chlorine in both of them, but one has a mass of 35, one has a mass of 37. Isotope, same element, different mass, because the protons stay the same. If you change the protons, you're changing the element and the atomic number. If you're changing the neutrons, you just change the mass. Number 5. Now, because you have isotopes, they all exist in different percentages or natural abundances, and so you're able to take a weighted average of all the naturally occurring isotopes to calculate the average atomic mass. So whenever you're doing this, you have 2 options. You can leave everything in the chart as is, divide by 100, or you can convert this to a decimal. So right off the bat, we can get rid of C and D because you are dividing by 100 or you are dividing by nothing. Now, that means we're going to have to convert our percents to a decimal. So what you do is take that decimal point, move it over 2 spots to the left. So this becomes 0.924, and this one becomes 0.076, which is our answer choice B. So it's this times this plus this times that, but your percentage is as a decimal. Number 6, the gold foil experiment led to the conclusion that 1, the atom is mostly empty space, so goodbye C and D. And again, we have a positive nucleus. Remember Rutherford's experiment, he shot gold foil with positive alpha particles. Most of those particles passed right through. You can only pass right through if nothing is there. So that means most of the atom is empty space. But every so often, the alpha particles, which he knew were positive, got deflected by something, and the positive charge only gets deflected by other things that are positive, making it B. Okay. Number 7, which Lewis electron dot structure is drawn correctly for the atom it represents. So remember, Lewis dot structures are talking about the valence electrons, or the outermost electrons for your element. So if you look at the periodic table, nitrogen should have 5 valence electrons, fluorine should have 7, oxygen should have 6, neon should have 8. So you just want to figure out which one has the correct number, which is D. Number 8, the elements on the periodic table of the elements are arranged in order of increasing atomic number. Remember, that's the same as the number of protons. That is what is unique to each and every element. Some elements have multiple oxidation states. That doesn't work. Mass number and atomic mass, that doesn't work either, although that's what they originally thought. But because isotopes exist, it throws off everything. The only thing that is unique to each element is the atomic number, or the number of protons. Okay, moving forward, number 9, which list of elements consists of a metal, a metalloid, and a nonmetal? So with this, use your periodic table and label it. Everything on the staircase is a metalloid. Everything to the left of that staircase. So here is your periodic table. Here is your staircase. Those are your metalloids. Everything here is a metal. Everything to the right of it is a nonmetal. So when you're labeling these, this is metal, metal, metal. Can't be that. B, metal, 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 can't be that. D, non-metal, non-metal. TE is a metalloid. Now we have some difference, but not everything. And then C, this is a metal, this is a metalloid, that is a non-metal. Don't be lazy, literally go check your periodic table. Okay, next, which list of elements includes elements with the most similar chemical properties? So if we're talking about most similar chemical properties, you want to be in the same group, which is that vertical column. They have similar chemical properties because they have the same number of valence electrons. They're going to do similar things to fulfill that octet rule. So looking at your periodic table, the only grouping of elements that are in the same group, that same column, is answer choice C. Moving forward, number 11, compare it to atoms of nonmetals in period 3, atoms of metals in period 3. So again, periods, we're talking about that horizontal row. It can't be C or D because if you are in the same period, you have the same number of electron shells. Again, if you forget that, look at your periodic table. They all have 3 numbers in their electron configuration, representing the 3 shells that they have. But metals on the left, nonmetals on the right, metals have few valence electrons, nonmetals have more valence electrons. So it's asking about metals, they have fewer valence electrons. Again, you don't necessarily need to have strong chemistry content, you just need to know how to look at your periodic table. Number 12, a solid element that is malleable, a good conductor of electricity, and reacts with oxygen. So even forget about this part if that confuses you. Malleable, good conductor of electricity, those are characteristics of metals. Non-metals, they are not good conductors of electricity, and they are brittle, meaning they cannot bend, they break more easily. Number 13, which electron configuration represents an atom of chlorine in an excited state? So you got to find chlorine on your periodic table, and chlorine has 17 electrons. So on your periodic table, you have the ground state, which is 2-8-7. So it can't be B because it's asking for excited state. Now when an electron gets excited, it just moves farther away. It doesn't duplicate itself. It doesn't magically poof away. So the number of electrons has to stay the same. So if you add up everything in choice A, you get 19 electrons. We're supposed to have 17, so that can't be it. If you count up all of everything in C, that's 18 electrons. Again, you're not magically losing or gaining electrons when they get excited. All they do is shift positions, and that makes it answer choice D. So you have your 17 electrons, and it does not match the ground state on the periodic table. Be careful, some questions ask for excited state, some ask for ground state. So make sure that you know what the question is asking you for. Number 18, in a calcium atom, in the ground state, electrons that possess the most amount of energy are located in the fourth shell. So the more energy an electron has, the farther away it is from the nucleus. So again, think of an excited dog on a leash. The more energy a dog has, the harder it's going to pull on that leash. Number 15, the bonds in BAO are best described as. So when you're asked about what kind of bond it is, you have to look at what makes up that compound. Ba is a metal, O is a nonmetal, and especially because we haven't gotten there yet, metal and a nonmetal is an ionic bond. Covalents are nonmetals only, so it can't be that. And then in an ionic bond, electrons are transferred. So the electron from the metal is removed and is given to the nonmetal. In covalent bonds, electrons are shared. But again, not what the question is asking. You have to look at what the compound is made of. Metal and nonmetal is ionic, and electrons are transferred. Number 16, the atoms are neutral because, again, neutral means you have zero charge. So that means the positive stuff has to equal the negative stuff. The positive stuff are the protons, and the negative stuff are the electrons. So protons equals electrons. That's why in atoms, protons always equal electrons, because atoms are neutral. It's not till when we get to ions where you're losing or gaining electrons, that's when things become a little bit more complicated and they don't equal each other. Number 17, which term represents the strength of the attraction of an atom has for the electrons? So the attraction of electrons is electronegativity. The more electronegative something is, the more it wants electrons. So generally metals have low electronegativity values because they're cool with just letting their electrons go, whereas nonmetals, they're closer and closer to fulfilling that octet role, those 8 valence electrons, so they want and they will hold on to their electrons more. Okay, moving forward, number 18, what is the approximate mass of an atom that contains 26 protons, 26 electrons, 19 neutrons? If we're talking about mass, or we're talking about protons plus number of neutrons, so 26 plus 19 gives you 45. Number 19, table sugar can be separated from a mixture of table sugar and sand at STP by adding, it's going to be choice D. Now for every unit except for gases, you can ignore the fact that it says STP. It stands for standard temperature and pressure, but 100% irrelevant to any question that you read. Now if you're mixing sugar and sand rather, sugar can dissolve, salt doesn't. That's why we have beaches. If sand dissolved, beaches would not exist. So when you add that water, the sugar is able to dissolve and the sand does not. Now you stir it, allow all of that sugar to dissolve. Now you have sugar water. So you have your sand and sugar, you can't tell the difference. When you add that water, the sugar dissolves everywhere and your sand stays on the bottom. Now if you were to pour that through a filter, your sand gets stuck because it's too big to pass through the filter paper, and what comes through is your sugar water. You can then evaporate your water to get your sugar back, but that is how that works. Number 20, which statement describes a concept included in the wave mechanical model? So this is just kind of a fact that needs to be memorized. Wave mechanical model is orbitals, so that most probable location. So your nucleus, it's not going to follow a perfect circle. It's going to be in a general area. Okay. Moving forward to the short answer questions. Again, when you're doing short answer questions, use as few words as possible. You want to keep stuff short and sweet. 21, explain in terms of element classification why K2O is an ionic compound. So if you're talking about element classification, an element can be classified as a metal, a nonmetal, or a metalloid. So if we're talking about ionic compounds, you know that K is a metal and O is a nonmetal. That's all you need to write. You do not need to write anything more. It's not asking what happens to electrons. You don't need to talk about that or anything else. Keep it simple. Number 22, explain in terms of protons and neutrons why U-235 and U-238 are isotopes. So as we said before, isotopes are the same element but a different mass. And if you wrote that as an answer, yes, it's accurate information, but it would be marked wrong because it's not what the question is asking you for. So an isotope is an isotope because the protons stay the same and the number of neutrons change. So you have to make sure if it says in terms of, whatever it says in terms of, that is in your answer. Okay. Number 23, state the general trend of atomic radius in the first 7 elements in period 3 when considered in order from left to right. So there's a few ways you can approach this question. 1, you can literally just look at the data given you. 2, you can use table S. For any periodic trend question, in case you don't remember what the shortcut is, table S has all of the information. Again, for a period, we're going across that way. But then I like the atomic radius snowman that's drawn like this. So as we're going across a period, the size of his nose decreases, so does the atomic radius. So all you have to write is that the atomic radius decreases. That is fine. I don't need a full sentence. It does not need to be complete sentences, short and sweet. Number 24, explain in terms of production of emission spectrum in terms of energy states of an electron. So when you need to write here, I don't care about how the electron gets excited. I just need to know that when the excited electron returns to the ground state, it releases energy in the form of light. So it doesn't matter how the electron gets excited, we just care that once it is excited, when it falls back down, that's when it releases energy in the form of light. This is probably one of the longest questions you will see. It requires the most amount of writing, but keep it short to that sentence. It is not a whole paragraph. Lastly, 25, identify the 2 gases in the unknown mixture. So you're going to want to match up every single line. So when you do that, the only thing that matches up is A and D. Again, that's it. Just give us the letters. Don't write a sentence. Doesn't matter. I don't care how they form. I don't care. It doesn't ask why you know it's A and D. Just say A and D, and that is it. So that's a pretty comprehensive review of the practice test. Hopefully that helps. Good luck studying for your quarterly.